So let's try to solve some problems in physics and some problems in chemistry, and if there is time in earth science, and discuss it together. Okay, so let's start with some problems in physics. He says here an auto travels at a rate 25 kilometer per hour for 40 minutes, and then 50 kilometer per hour for 8 minutes, and finally 20 kilometer per hour for 20 minutes. What is the average speed for the complete trip? What is the average speed?
Distance over time.
Total distance over total time.
Yeah.
So we need here to calculate the total distance and divide it over total time. How to do that?
We multiply time by speed to get the distance first.
Okay, so the distance equals the speed times time. So I have here 3 periods. He travels at 25 kilometers per hour for 4 minutes. So I will multiply 25, which is the speed, times the time, 4 minutes. But I have to change it into what?
Over 60 hours.
Over 60 to change it into hours. Plus the second period. He drives at 50 kilometers per hour in 8 minutes. So multiplies time with 8 times 8 over 60. Then 20 kilometers per hour in 2 minutes. So 2 over 60. So this is the total distance divided by the total time. I have the first time is 4 minutes. The second time is 8 minutes. The third time is 2 minutes. But take care that all of them in minutes, you need to divide them over 60. You need to change them into hours. But as you see here, I divide over 60 here and here and here. And also I divide in the denominator over 60. So what do you think? We can remove the 60 or leave it or what?
They will cancel each other.
They will
Remove
cancel
it.
each other. So you don't need to leave it in your calculation. Just cancel it. So I will cancel the 60 in my calculation, so it will be much easier. So could you please, guys, calculate the result? Please use your calculator.
38.57.
30 what?
8.5714.
Kilometer per hour. Okay. Okay. MashaAllah, here he gives like how many choices? 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8. 8 choices in the problem. A person releases bowling ball from wrist. It rolls down a ramp. So this ball starts from wrist, the initial is 0, and rolls down a ramp with a constant acceleration. Constant acceleration, so you will need to use the 3 equations. What are the 3 equations? V final equals V initial plus AT. V final square equals V initial square plus 2A times distance. And the distance equals V initial times T plus half times A times T square. So these are the 3 equations that you cannot go to any physics exam without them. If you go to any physics exam, you must remember these equations. Okay. It rolls down the ramp with constant acceleration. After half second, it has traveled 0.75 meter. So when the time is 0.5 second, the corresponding distance is 0.75 meter. Like when it reaches here, for example. How far has it traveled after 1.7 seconds from the beginning? So if the time is 1.7 seconds, but from the beginning, what is the corresponding distance? What do you think?
You need the acceleration first.
We need acceleration first. Okay. Can't we use the third equation and we make it like a ratio? Let's try it. Let's try to do a ratio using the third equation. I know that because the initial speed is 0, so it will be easy, inshallah. Using the third equation, it's a relation between distance and time. In the first case, time is half, distance is 0.75. So the distance, 0.75, equals V initial t, which is 0, I don't need it, plus half times acceleration times t squared. And the time here is what? 0.5. So this is the first one. Let's do the same with the second time. Let's use the other information and let's call it D2. So the distance in the second case equals also V initial times T, which is 0. Because he said from the beginning. So V initial was 0. Plus half times the same acceleration times time, which is 1.7 square. So here I have two equations. I can solve them easily. We can divide them over each other. So this one over this one equals also the same. So 0.75 divided by the second distance equals what? Half goes with half. Acceleration goes with acceleration. Easy, half square over 1.7 square. So could you please calculate the distance, D2? Everybody, please try to do it using your calculator. Please bring a calculator and try it.
8.67 meter.
So this is the distance, 8.67. Of course, there is another way. You can use the first time and first distance, plug it here to find the acceleration. Then you can plug it again in the same equation and you know the acceleration, so you can find the corresponding distance. But I think that my method here is faster. Okay, but it's up to you. If you want to find the acceleration first, it's up to you.
So, doctor.
Yep.
If he didn't mention in the question that we had constant acceleration, then we can't use the first method, right?
Actually, in this course, we use constant acceleration in this course. But inshallah, maybe in Physics 101, you will use different kinds of acceleration. And when you study engineering also, you will study different kinds of acceleration. But in our course here, usually we use constant acceleration. Okay?
Okay, thank you.
Doctor, how do you find the acceleration in this question? Which
the same equation. The same equation. Distance is 0.75 equals V initial t, which is 0 plus half times acceleration times 0.5 square. So you can find the acceleration here. It will be 0.75 times 2 over 0.5 square. So you will get the acceleration directly.
Okay, thank you.
You are welcome. Okay. I need to erase it so you don't get confused. I think this one I solved one like this before in one of the videos. Okay, let's see this one. A helicopter is traveling at 40 meters per second east. So there is a helicopter. It's moving to the east at 40 meters per second. It's a good helicopter here, and this is a driver. He's a pilot, actually, not a driver. At a constant altitude, 100 meters. So it's altitude 100 meters. This is H. If a wheel falls off, one of the wheels will fall off. With what speed will it hit the ground and neglect air resistance? So if the wheel falls off, do you think it falls off vertically downward? What do you think?
Yes, of course.
No, because
gonna
the
be
helicopter itself is moving at 40 meters per second. So any object that leaves the helicopter, it must have initial speed as the helicopter. So this wheel will have the same speed of the helicopter at the beginning. So let's remove the helicopter and let's look at the wheel. The wheel will start with the same speed of the helicopter, which is 40 meters per second horizontal. Then because of the gravity, it will move like this. So it's like a projectile. It is a projectile, actually. Okay. He asks about what? What is the speed when it reaches the ground? We need to find the speed as it reaches the ground. And when he says speed only, when he says speed, that means he needs total speed. Okay? If he says only speed, so he needs total speed. The total speed of the projectile has two components. There is a horizontal one and there is a vertical one, and this is V. V is the root of Vx square plus Vy square. This is the total speed. Vx is what?
40.
40 meters.
Exactly like the initial speed because it's horizontal. Okay. Vy, how to get Vy?
0. Or
Nope. Cannot be 0. It was 0 at the beginning. We call it Vy initial. It's 0 at the beginning because the projectile is moving horizontally. But because of the gravity, you pull it down. You pull it down, so Vy increases because of the gravity. So Vy, actually, we can get it from the equation. Vy square equals Vy initial square plus 2 times G times H. Of course, Vy initial square is 0. So Vy square is 2 times G times H. Or Vy only, it's root of 2GH. But we don't need the root. We can keep it square because we will need it as a square here. So 2 times 9.8 times height. The height is 100 meters. Okay. The height here is 100 meters.
1960.
1,960.
1960. So we will plug it here, and also the 40 we will square it. So the speed is Vx square, which is 800 plus Vy square, which is 1960. So the result is what?
52.53.
52?
Yes.
60. 59.665.
59.66.
I
Yeah,
got
I
a
think
number.
You got it?
I got another number for some reason.
Okay, please do it again. Do it
Doctor.
again.
Yeah, same number.
Got it?
52.535.
Why?
No idea.
Do you have your calculator on a different
Yeah, I
mode?
just did on the calculator. 800, the root of 800 plus 1960.
No, you don't. You take 800 plus 1960. Then after you find the result, take the root.
Oh, let me try that. 19.
So you put it like in brackets like this.
7,
Then take the root after you finish the addition.
It's gonna be root of 2760,
Which is what?
which is the same answer, 52.53.
Oh man. How is it? There must be something wrong with the calculator.
I get it the same.
52 also?
Yes,
So maybe we did something wrong.
maybe.
Let me do it myself. Okay, the root of 800. Oh, we did something wrong. Sorry. 40 square.
Squared plus 1960. Yeah, now
So
it's
not
gonna give
800.
it
We
9
did
point.
something wrong. Yeah.
Yeah.
Doctor.
Yes. So
We can
now
also, yeah, I just wanted to ask, we can also use the law straightforward, right? We can just use VF squared equals VI squared plus 2AS, right?
this is the one
Yeah.
that I have used here.
Yeah, but we can just plug in 40 as VI. It's going to be the same answer, right?
Again.
I'm saying we don't need to use Vx squared plus Vy squared. We can just plug 40 in Vi.
You need to plug 40 in VI. Why?
Yeah.
No, you cannot do that.
But it gave me the same answer.
Yes, but you cannot. Physically you cannot do that.
Oh, so
Okay.
it's not going to work like that.
Don't
So I
think
can't
it.
do that basically.
You know, I will tell you why you get it like this.
Okay.
You might use the equation of mechanical energy. The mechanical energy at the beginning equals the mechanical energy at the end. Okay, so this is another method for solving the equation. I will tell you why you get it in this way. So the mechanical energy at the top, in case number 1, it has two kinds. It's kinetic plus potential. And at the end, it's only kinetic because there is no potential. The kinetic energy at the beginning, it's half times m times v square, which is 40. And the potential energy is m times g times h, and h is 100, equals half, the kinetic energy in the second case, half times m times v final square. And he's asking about this v. He's asking about v final here, this v. So I remove mass with mass with mass. So it will be half v1 square plus gh equals half times v square. So if you multiply times 2, if you multiply all the equation times 2, this one is cancelled, this one is cancelled, and there will be a 2 here. So this 2gh is this one, okay? And this is v final that I'm searching for. And this initial v is the 40. It's not the initial speed for the equation of the constant acceleration, the equation of constant acceleration. V final square, it's v initial square plus 2a times g or times h, whatever. The 40 is not this one. Okay, it's something different. It comes from the equating of mechanical energy at the beginning to the mechanical energy at the end. And the coincidence here is صدفة that they are the same. They are the same exactly here. Okay? But physically, you cannot use it in the vertical equation. But as you do it here, you did it and it's right. but it's not right because the equation itself is right. It's right because you used another equation, which is the mechanical energy equating. Okay. Do you understand this point?
Yeah.
Okay. So sometimes it's good to make a mistake and you get the right answer. Let's see something else. Yeah, that's an elevator. A person whose mass is 80 kilogram is standing on a scale inside an elevator, descending at 10 meters per second. What the meaning of descending? يهبط أو ينزل.
Slowing down.
No. Descending means the direction the elevator is moving down. This is an elevator, has somebody here, and the elevator itself is moving down. But he doesn't say anything about acceleration yet. We will see it in a minute. The elevator takes 3 seconds to brake to a stop. So the elevator is moving down, but it brakes until it stops. So what is the direction of acceleration here?
Upwards.
Upward.
Yes. So take care of this issue. The speed is downward, or we should say velocity, not speed. The velocity is downward. And he has a brake. Okay. So the acceleration brakes. So the acceleration is opposite. So the acceleration is upward. So take care of this issue. The elevator takes 3 seconds to brake to a stop. We find that 0. What is the reading of the scale? So the initial speed was 10 meters per second. V initial was 10 meters per second. V final is 0, time is 3. So what's the acceleration here?
10/3.
We should say delta V over the time.
Yes, on
V final minus V initial. So it's 10/3. It's 3.33 meter per second square. It should be negative.
That should be negative.
Because it's deceleration. But I will not write down the negative because I know it will be upward. It's opposite to the motion. So negative here means it's opposite to the motion. So I did it upward. So I don't need to write down the negative here. He asks about what? The mass is 80 kilogram. What is the reading of the scale? What's the reading here? The reading is the normal force equals the weight of the object plus or negative minus. Is it plus or minus?
Plus.
Plus. Mass times acceleration. Of course, W is mg, so it's mg plus A. Or mg plus ma, it's up to you. The mass is 80 kilogram. Gravity, I know it's 9.8. Acceleration is what? 3.33. So what's the result?
1050.66.
1050 point whatever Newton. Okay, so take care that the acceleration is opposite because it's a brake. Okay, guys?
Doctor, we said plus because the acceleration is upwards?
Yes.
Okay.
A football kicker imparts a speed 30 meters per second to a football. The football was at rest. So he will kick the football. The initial speed of the football is 0. Or yes, let's make it initial. If the football has a mass, half kilogram, and the time of contact with the foot is 0.025. the time, or delta t if you want to write it, delta t 0.025 second. So he applies a force by his foot. This force is F. He applies this force for this time. So this force will give a speed or a momentum, whatever you call it, to the ball. How much force is exerted on the foot? The force exerted on the foot is the same as the force exerted on the ball. Okay, so the foot exerts, this is the foot, it exerts a force on the ball. Also, the ball exerts the same force on the foot. Okay, Newton's third law. So I will calculate the force which is exerted on the ball, and it will be the same as the force exerted on his foot. What are the information I know? Football kicker imparts a speed 30 meters per second. So the final speed is 30 meters per second. So here I need a force. I have initial speed, I have final speed, I have time, I have mass. So I'm talking about which equation?
Impulse, momentum equation.
Impulse and momentum. Excellent. So force times the time or the period equals the change in momentum. Change in momentum is mv final minus mv initial, or I can take mass as a common factor. It will be mv final minus v initial. Take care that the v here is velocity. Okay. So the force times time, which is 0.025 seconds, equals the mass, which is half kilogram. V final 30 meters per second. V initial is 0. So the force is what? 15 over 0.025. Huh?
600. Yeah.
100
Yeah.
Newton. Okay, 600 Newton. Let's see something else. Guys, if you have any question, please directly ask me. Somewhere between the Earth and the Moon, somewhere between Earth and Moon is a point where the gravitational attraction of the Earth is cancelled by the gravitational pull of the Moon. Like if we have the Moon here, and we have, what happened? And we have the Earth here. Somewhere in between, like let's say in this point, for example, the two forces are the same. This point should be very near to the Moon. The pulling force or the gravitational force of the Earth equals the gravitational force of the Moon. That's what he said. The gravitational attraction force, the gravitational attraction of the Earth is cancelled by the gravitational pull of the Moon. So they are equal. The two forces are equal in this point. The mass of the Moon is 1 over 81 of the Earth. The mass of the Moon equals 1 over 81 the mass of the Earth. Make it big one. How far from the center of the Earth? So we measure from here. This is my origin. So we need to measure a distance. How far from the center of the Earth is this point? Okay. So let's take, this is the object here. What is the force of attraction from the Earth? The force
0.
of gravity of the Earth. No, let's take the Earth and the object itself. It's G times what? The mass of the Earth times the mass of the object divided by the distance square. This is the distance from the Earth. So the distance from the Earth square. Okay? Because here there is a distance. It's not on the surface. So we cannot use the radius actually. We need to take the whole distance, this whole distance. Also, the gravitational force of the Moon is the same. the gravitational force of the moon is the same. We also have a distance from the moon. So it will be G times mass of the moon times mass of the object divided by the distance between the object and the moon. Of course, we take from the center of the moon to the center of the object square. The two forces are the same. So now we can equate them together. Now let's equate them together. Okay. When we equate them, what will happen? G goes with G. Mass of the object goes with mass of the object. Mass of the Earth, I can cancel mass of the Earth and write it down 81 times mass of the moon. So now I can cancel mass of the moon with mass of the moon. So at the end, what's the leftover? 81 divided by the distance to the Earth square equals what?
1 over
1 over the distance to the moon square. So now we can solve it. Okay. Let's take the root of everything. Let's take the roots, a square root. So the distance to the Earth and the root of 81 is 9. And the distance to the moon here and root 1 is 1. So let's rewrite it again. Flip everything, or I can say the distance from the Earth equals 9 times the distance to the moon. So the distance from the Earth here, it's 9 times the distance to the moon. Okay. So which one should I choose?
First one.
Yeah, it's 9 over 10. If we say this is 1 time and this is 9 times, so the total is 10. The total is 10. So as a fraction, this is 9 over 10 of the distance, and this is 1 over 10 of the distance as a fraction. So it's 9 over 10 the way from the center of the Earth to the center of the moon. So it's not 9/10 the total distance between the Earth and the moon. So this is the right one. Okay. Do you want me to repeat it again? Huh? Should I repeat it again, guys? Okay. Let's see something about the gases. Okay. Suppose you take a whole deep breath. Suppose that you take and hold a deep breath at a chilly day. So it's cold. Inhaling 3 liters of air. So the volume that you inhale in your lung is 3 liters. The temperature of that day was 0 degrees Celsius. At 0 degrees Celsius. Assume that the air pressure is constant inside and outside your lung or your body. How much will be the volume of the air as it warmed inside your body to 37? So you take some air and then you keep it inside. You hold it inside your lung for maybe like 1 minute. So its temperature increases. From 0, it becomes 37 degrees Celsius. Of course, the volume will increase. So if this is V1, this will be V2. So what will be the second volume? This equation is what?
Charles law.
Charles law. That's right. So V1 times or divided by?
Times.
Divided by. V1 over V1.
That was Boyle.
Equals, yes, over V2. The most important here, do not forget what?
To change.
Convert.
Kelvin.
Kelvin, yeah, that's the most important because like most of us forget actually. V1 is 3 liters. 3 liters. I don't need to write the liter. V2 is unknown. Temperature 1 was 0, so 0 plus 273. And temperature 2 is 37. 37 plus 273. 300 gives you
310.
310. 310. So what's V2? 310 times 3 divided by 273.
3.3 liters.
3 point what?
46 liters. No, 40 and then 6.
Like
40.
this?
Yeah.
Okay. So it's almost 3.4 whatever liter. Match between the name of the principle with its corresponding statement. Boyle's law, Bernoulli principle, Pascal principle, Charles law, Archimedes principles, Newton third law. Let's see the first one. At a constant temperature, the volume of the gas is inversely proportional to the pressure. Boyle, PV, P1 V1 equals P2 V2 equals a constant. So the P is inversely proportional to the volume. That's Boyle's law. When the flow of the fluid is restricted, the speed increases. That's Bernoulli. Okay. If you have a tube and the fluid goes to a smaller tube, the speed increases. When the speed of the fluid increases, its pressure decreases.
Pascal.
It's the same, Bernoulli.
Should be Bernoulli. Okay. So when the pressure here.
It speaks about pressure.
But it has nothing to do with the speed. This is Bernoulli. This should be Bernoulli. Okay.
Yeah.
Because we said before, Pascal has no speed. Pascal, it's talking about pressure and forces and areas. So there is no motion in Pascal actually, or there is no flow, not no motion. It's no flow. لا يوجد سريان. But in Bernoulli, there is an area A1 and area A2. This area is big, so the speed is small. The speed on the other side is higher. So V2 is greater than V1. What about the pressure? Do you remember? The pressure here is high, while the pressure on the other side is low. So the lower the speed, the higher the pressure. The lower the speed, the higher the pressure. So the speed and pressure
inversely proportional.
Yeah, they are inverse here. They are inverse here. So here he says the speed increases and the pressure decreases. So that's also Bernoulli. Okay. In a fluid at rest, so a fluid at rest, so we might talk about Pascal.
Yes,
in a closed container, so it's very close to Pascal. A pressure change in one part is transmitted without loss every portion to every portion of the fluid. So that's Pascal. Okay. The pressure transmits throughout the fluid. Okay. In a closed container, and the fluid must be at rest. Okay. So that's Pascal principle. Okay, guys. Let's see something else. Choose the correct classification of each of the following type of matter. Baking soda is what? We have here elements. We have element, compound, homogeneous mixture, colloid, suspension, non-matter. Non-matter.
Combined.
Baking soda is what?
Compound, yeah.
Compound.
And ACO3, I think.
Air, huh? Air is what?
Mixture.
Homogeneous.
Homogeneous mixture. It has O2, CO2, N2, and so on. Okay, so all of them are mixed together, so it's homogeneous mixture. Fog, colloid. Helium, element. Smoke,
Colloid.
colloid also. Okay, smoke and fog are colloids. Choose the correct element for the following statements. It has 78 protons. Look at the periodic table. Look at your periodic table. What is the element that has 78 protons?
Platinum.
Platinum. That's right. Okay, so if you look at the periodic table, number 78 is platinum. Platinum. The first three energy levels are completely filled with electrons. At the last level, which is the fourth level, contains only 6 electrons.
We look at the fourth row and 16th column.
So an element that has 4 levels. So that's row number 4. Row 4. And the last level has 6 electrons. 6 electrons. So we are talking about which column?
From 16.
Column 16. So row 4, column 16. Look at your periodic table.
Doctor, speaking of periodic tables, are we allowed to bring a printed periodic table?
The coordinator sent a periodic table to you. He sent one, I think, last week.
We can't print it like to differentiate between the metals and non-metals?
You need to print it, actually. You need to print it.
Yes, but can I shade the non-metals so that I can differentiate between them and the metals?
It's very easy. It's very easy to differentiate between metals and non-metals. And usually you will find something like this, like a ladder in the periodic table.
Yeah.
Okay, so it tells you the metals to the left and the non-metals and metalloids are to the right. And there is only one non-metal, which is the hydrogen to the left. Okay, so it's very easy.
Okay.
So, level row number 4, column 16. What is it?
Selenium.
Selenium. It's located in a group number 18. So that's column 18. And period 5. So row 5 and column 18. 5 and 18.
Xenon.
Xenon. Xenon. It's a metalloid. So is it germanium, bismuth, cobalt, sulfur, or oxygen? Which one is the metalloid? Germanium. The germanium is a metalloid. We have 8 metalloids: boron, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. Okay. It has similar chemical properties as antimony. Where is the antimony? It's number 51. Same chemical properties, so it's same column.
Same column. Yeah.
Same column. Which one has the same column like the antimony?
Yeah.
We have bismuth, arsenic, phosphorus, nitrogen. Which one of them is here?
Bismuth.
There is bismuth, so it's bismuth. Bismuth. Okay. So this is some kind of questions.
Doctor?
Yes.
Chemical properties are alike in the same column,
Yes.
right?
Yes.
Okay.
Yes. Okay. Let's solve another one question before we finish. Let's look at the compounds. Choose the correct type of chemical bond in each of the following. Na2S, sodium with sulfur.
Ionic.
It's ionic compound. NH3.
Covalent.
Okay, it's covalent. Is it polar or non-polar bond? Because here I have polar covalent and non-polar covalent.
Polar.
Nitrogen has how many electrons? Huh? In the dot diagram.
5.
5.
Five.
1, 2, 3, 4, and 5. It will have 3 bonds with hydrogen. 3 covalent bonds with hydrogen. Of course, all of these bonds are what?
Single bonded.
Single polar. Polar bond. Because nitrogen is stronger.
Because it has more electronegativity.
Of
Or
course. Okay. So it's polar bond. N2.
non-polar.
Non-polar. SO3. Sulfur with oxygen.
No, ionic.
No.
No.
Sulfur. Sulfur and oxygen, they are in the same column.
Covalent.
It has covalent. Polar or non-polar?
Polar.
Polar. Polar. Okay, because oxygen is the strongest after fluorine. Okay, so oxygen is very, very strong. So it's polar. Polar. MgO. Magnesium with oxygen.
Ionic.
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 Is that enough?
Doctor,
Yes.
I just wanted to ask, with the physics questions, we'll have compound questions, right? The ones that combine 2 ideas or more.
In physics?
Yeah, in the test.
What about it?
I'm just asking, like, we're gonna have questions that combine 2 ideas,
Maybe.
Well,
Maybe.
like momentum and mechanical energy.
Although I don't think so, but maybe it will happen. Yeah. Okay. In physics, you can expect anything. Okay, but I don't think so, because usually it's multiple choice. So I think in the multiple choice, he gives you one idea.
Oh, okay.
That's what I think.
Doctor,
Okay, guys.
I wanted to ask about the matching questions when you match two columns together. Can there be 2 answers for one one choice?
Sometimes it happens. Like here, we said that when we said Bernoulli, we chose it 2 times. You remember when we chose Bernoulli 2 times? Like here. We
So
chose
it could be more
Bernoulli,
than once.
this one and this one. Yes. It happens. But you need carefully to think. You need to think about it carefully before you choose or repeat the same choice. But it happens.
Okay, thank you.
Okay, thank you so much, guys.